Welcome to UC Collaboration, a global name in unified communication, formerly Voice Bootcamp. Hi, my name is Faisal Khan, CEO and founder of UC Collaboration. In this CCIE Collaboration and CCNP Voice Foundation Kit, we're going to focus on gateways and protocols. Here we're going to talk about H.323 Voice Gateway, SIP Gateway, MGCP Gateway, and Cisco Unified Border Element. Now, this is just a brief discussion about these protocols. We will go into details about each one of these protocols in the subsequent chapters. A gateway provides a number of methods for connecting IP telephony network, such as your call manager, to a public switch telephony network, such as Verizon, BSNL, or Bell Canada, for example. A traditional voice gateway, such as Cisco router, with a DSP chips, digital signal processor, is designed to interconnect VoIP and TDM network. It allows you to switch calls between analog to digital and vice versa. So basically what the voice gateway does, receives signals from your service provider, the old telephony system, as a TDM traffic, and then convert it to IP data packet. Then you have the next generation VoIP gateway, or CUBE, Cisco Unified Border Element. It's basically a Cisco router with a special iOS feature set that allows you to interconnect two logical separate voice network. A traditional voice gateway cannot allow VoIP traffic to be sent to another VoIP network, but CUBE will allow you to do that. This is where the SIP trunking plays a vital role. Now, whenever you buy a gateway, always have to keep in mind that redundancy should be a consideration for high availability environment. In order to configure our voice gateway to communicate with our service provider using the old technology such as ISDN or T1 and E1 TDM technology, we must first configure the router to communicate with the service provider with various ISDN related settings. One of the first things that we need to ask our service provider is what kind of switch we're connecting to. So we need to define the switch type. Now we also need to define your network clock for clocking purposes, such as network clock select and network clock participate week 2. These are your slot number where your voice card is in. Now, Cisco router supports three type of voice card. You got VWIC, the first generation, VWIC 2, the second generation, and then you have VWIC 3. Now, a VWIC 2 is basically a single interf card that can be act as a T1 or E1 just by changing the card type in the router. In VWIC 1, the first generation, either you buy the card as a T1 or you buy the card as E1, so you cannot switch them in between. Now, if you do have a VWIC 2 or 3, and if you do not define the card type, what's going to happen is when you tap show run, you will not see the controller in your router. Now, once we decided that whether it's going to be T1, E1, depending on your location, if you're in North America and Japan, you're going to use T1. Japan, they call it a J1. Whereas for rest of the world, you're going to use E1. Now, when you configure T1 E1, one of the few things that we need to define is your framing, your line code, and the group slot, number of time slot. Now, framing and line code will be provided to you by your service provider. Depending on what they're using, you must use that. Now, time slot is depending on how many channels you have purchased. So you may have got the entire E1 or T1, or you may have got a fractional of it. So you need to define that many number of time slot. Now remember, if you have purchased 12 time slot but you have configured 1-24, what is going to happen is the remaining time slot beyond 12 will not be in service, and you may end up sending calls to a channel that is not active, and you will see an error message saying channel no circuit available. Now that is the TDM side. Once the TDM side is dealt with, then the next step is to configure the VoIP side. Now, when two gateways to communicate with each other, they must speak the same language, or the protocol for that matter. So the choice of protocol that we have is H.323, MGCP, SIP, and SSCP. H.323 and SIP are both peer-to-peer technology. What does that mean is that both gateway requires to maintain his own dial plan and route pattern, and both gateway act on his own. There is no one gateway does not control the other gateway. Whereas MGCP is a client server, is a simplified configuration in which call manager acts as a server, but the gateway acts as a client, and call manager maintains the dial plan. SSCP is a proprietary protocol for Cisco, in which case Call Manager is a server. It is also a client server. It maintains a dial plan, but it only is deployed for Cisco IP phone or analog gateway from Cisco, such as VG248 or 224. Now we're going to go into details about H.323. H.323 is a peer-to-peer protocol, as we talked about. Now, one side of the gateway will be connected to the traditional TDM, PSTN, while the other side will be connected to the IP side. Now, all the PSTN signals, such as your ISDN signal that are coming from your service provider, will come into the router using your T1 or E1 cable, using PRI signaling for that, for example. Now, when you do receive the signals, it will terminate into the router. The router will analyze the packet that is coming in and then make a decision based on that. So the two type of packet that is coming into the router is called ISDN Q921 and ISDN Q931. Now these two packets are very important. Well, especially the Q931 is important to us. Q921 focus on the layer 2 connectivity between our router and the service provider. But Q931 focus on the layer 3 addressing. Now Q931 is where you will see the caller ID, the number that the user have dialed, their name, the reason why they called, also not the reason why they called, the reason why the call got disconnected or not connecting, and which port the call came through, which channel rather. Now one of the important thing about Q931 that Q931 contains the phone number that user actually dialed to reach your destination or the destination number. The router will intercept the packet Q931, look at the dial number or DNIS, and then take that number and makes a decision as to what to do. So therefore, because the router is intercepting the Q931 message which contains the destination number, the router has to know how to deal with that number. And how does the router deal with it? By looking its own dial plan. So therefore, we must configure a dial pair on the router. So in H.323 environment, you must have a local dial plan on the router to satisfy that incoming call that is coming in. Now that the router knows that I'm going to have to send the calls to this IP address and I'm going to use H.323 Gateway, the reason why this dial pair shows an H.323 Gateway, out of the box, every dial pair, VoIP dial pair by default is H.323 protocol. You can change that to SIP if you want to, but by default is an H.323. So what's going to happen at this stage is when the router match that the destination number 197.2.306.3001 to this dial pair, is going to send a signal to this IP address, which happens to be the call manager cluster. So it's going to send an H.225 and H.245 signaling using a TCP port 1720. Now H.225 is the call setup. That's when the phone is ringing. But H.245 basically negotiate the codecs and other capabilities. Now usually both of them is initiated at the same time in the most modern gateways. When both of these packets are initiated at the same time, we call that concept fast start. But if H.225 in the older generation, you will have H.225 initiated first. Once that is successful and acknowledged, then H.245 will be initiated. Anyway, so the call from the gateway will then ultimately come to the call manager. Now when the call manager will only accept the call from this gateway if you add that gateway into the call manager database. So therefore, one of the tasks involved in configuring an H.323 gateway is to add that gateway into call manager. Now, because in the nature of H.323, they do not exchange information between each devices, so call manager does not register the gateway. It simply adds it and then send a ping signal to see if it can communicate. So the gateway status in call manager will always remain unknown. So the two key things you have to keep in mind. A, that the call manager does not exchange data with the gateway or control the gateway. So therefore the gateway registration remains unknown. So don't go and start troubleshooting that. Two, the gateway records a dial plan because its gateway is the one that is intercepting this packet ISDN Q931, which contains a number that tells what to do. So once a call comes to call manager, Call manager will also look at its own dial plan and try to find how to route the call for 1972.306.3001. There is various translation that can be done, and there's other stuff that can be done to resolve this problem. So that's the basic of H.323 gateways. Next gateway we're going to focus on is SIP. Now SIP is Session Initiator Protocol. It's based on ASCII technology, ASCII character. And SIP was designed based on existing protocols such as internet-related protocols such as HTTP, DNS, SMTP, RTP, so and so. The advantage of SIP, because it is designed based on internet protocol, a lot of software developers in the market are already familiar with the various syntax and messages of SIP because they are dealing with the web programming. And SIP is based on those, since SIP structure is based on the internet protocol, makes it easier for developer to develop application. Now SIP is a session-based protocol. That means it will initiate a request and get a response and decide to establish a communication or not. Now in SIP environment, the phone numbers or extensions are addressed very similar to email address. So it will be like extension at IP address or extension at domainname.com. Now just like H.323, in SIP you will have PSTN signal coming into the router, such as ISDN-Q921 and ISDN-Q931. Remember, ISDN-Q931 contains what? One of the most important thing that makes a router decision, the destination number, a dial number. So the router has to have a dial plan matching that dial number. So therefore we also have to have a dial plan or dial pair in SIP. Now look at the difference between H.323 dial pair. If I go back, this is the H.323 dial pair and this is the SIP dial pair. So what's the difference? Well, we converted this dial pair to SIP by saying this following command: session protocol SIP v2. Now this dial pair is no longer default. Remember, the default, every VoIP dial pair that we create by default, it is an H.323. Whereas in this particular case, it is SIP version 2. Again, the call will go to via SIP to call manager. In order for the call manager to accept calls from this particular gateway, we must add a trunk. Now, there is no such thing called SIP gateway from a call manager perspective. No, there is no single gateway that you can add it as a SIP. What you have is a trunk. So don't go under the gateway section and try to add a SIP gateway. No, you're going to go to device menu and then go to trunk. So it's a logical connection between a call manager and the particular router. MGCP gateway, on the other hand, is a client server. It's a very simple endpoint which can either be analog or digital. Now, in order for MGCP to work, MGCP depends on call manager acting as a call agent, and the gateway act as slave. It's a master-slave relationship. MGCP messages are sent over UDP between the gateway controller and the gateway itself. Now, again, you will have ISDN signals comes into the router. The only difference here is the router, we do not allow the router to analyze the Q931. What we do, we let the Q931 be analyzed by the call manager. How do I do that? In my router, under the D channel, I'm going to say bind ISDN bind L3 CCM manager. By typing this command, what am I telling the router is that please do not intercept the Q931 message. Let that message pass through, and let it go to the call agent, which happens to be the call manager. Call manager receives the ISDN Q931 and open up the packet and look for the destination number. So remember, it is not the router that's looking at the destination number. The call manager is in this case because the Q931 is passed to it. Because the router is not looking at the ISDN Q931, therefore we do not need dial plan on the router. However, we do need dial plan on the call manager. So of course, once the call manager will convert that number to 4-digit extension, and everything should work fine as per the requirement. The next generation voice gateway, or Cisco Unified Border Element, which is basically an IP to IP gateway, interconnect VoIP networks. Sometimes we also call this session border controller. It is implemented on Cisco iOS gateway using a special iOS release. it has the ability to connect one dial pair with another. Now, one of the advantages of this particular gateway is that one side of the gateway could be an H.323 while the other leg could be SIP. So you may have a customer where in your organization you choose to use SIP, but you are dealing with a customer who may not support SIPs. They may have a H.323. So in that case, Cube can, or UBE can provide interconnectivity or inter-networking between the protocols. Another advantage of running Cube is that you can do proxy signaling, such as here, H.323 to SIP, SIP to SIP, so and so. You can do also proxy media. Now we know that from our basic voice over IP knowledge is that once the call is established, the RTP or the media traffic is directly between the endpoint, such as the IP phone to IP phone or IP phone to analog digital gateway. However, in this scenario, if I enable proxy media, all traffic, even including the RTP, will go through the router. Not between the IP phone to IP phone, but between the IP phone and the router to the other IP phone. So both RTP as well as signaling will pass through the router. Now, one of the advantages of doing that is that you're hiding your internal network from the outside world. Second, you may not want each other to find out about their IP addresses. But disadvantage to that is that a lot of traffic will pass through the router, so therefore the the CPU utilization could be quite high. Single point of failure requires higher bandwidth, so and so. So Cube has some advantage. One of the reason why you want to use Cube is because of SIP trunking. It allows interconnection between your organization and the SIP service provider. So in a conclusion, that H.323 and SIP gateway provide decentralized management of dial plan, where SIP protocol is based on ASCII. Both H.323 and SIP ISDN Q9 traffic terminates on the router. Basically that's where the router is going to analyze the destination number and makes a decision of what to do next by looking at its own dial plan. MGCP gateway on the other hand is a centralized protocol, and Cisco Cube is a next generation voice gateway designed to provide IP trunking between H.323 and SIP network. So that's pretty much it for this chapter, and I will see you in the next.